Pythagoras' theorem. Lots of theorems in this. A theorem is kind of like a rule. It's something that's been found and proved to be correct. So therefore it's a theorem. We met this back in year 10. We're probably pretty good at it. What we've got to remember is that we're dealing with right-angled triangles. All right, so right-angled triangles. And as long as we remember that, we will be right. So the theorem for a right-angled triangle is that a squared plus b squared equals c squared. All right? So we can use this two ways. We can use this to find a small side and we can use it to find a large side. When we're adding together, we can see that to add together gives us something bigger. So C has to be the big side. If we were looking for the smaller side, we need to minus. So normally it's easier to write it as C squared, the hypotenuse. We knew that, didn't we? Hypotenuse is equal to the two small sides squared added together. But if we got one of the small sides that we're looking for, then we need to use the hypotenuse, the long side, and subtract the other small side we know. All right, so it's always the same working. The difference is just whether it's a plus or a minus. So plus to find something bigger, minus to find something smaller. Let's have a look. We should always write all of our working out. So if we say that this is K, and we've got 6 and 8, check that there's a right angle, all right? We're going to say K squared, which is the hypotenuse, equals 6 squared plus 8 squared. So that's 36 plus 64 equals 100. K equals the square root of 100, and it's always the positive square root because we're talking about a length. So K equals 10. All right, we should always have lengths, so centimetres all over the show. We've got centimetres in our answer. And if we've used our calculator and we get some sort of decimal, we should always have our accuracy after it too. So, for example, 1 dp. This isn't 1 dp, but that's okay. That's the sort of statement we should have. All right, so if we've got, let's have a look at another one. Right, we've got this one. I'm using easy ones because I haven't got a calculator at the moment. But if I had a calculator, I could do the square roots. So in this case, we've got p squared as the smaller side, so it's the longest side, 5 squared, minus the other side, we've been given 4 squared. So we've got 25 minus 16 equals 9. What squared equals 9? 3. All right? So that's how we get to our answer. Make sure you write your working carefully. Make sure you double check it. The worst mistake in this is forgetting to square, believe it or not. People just jump straight from here to 6 plus 8 equals 14 and take the square root. So they kind of know what they're doing. But without those squares, we haven't made it big enough to make it smaller. So we have to relate it to the squares on the sides of the circles because it's the square on this side and the square on that side is equal to the square on that side. That's how it works. You can look it up online. Some really good visual displays of how it works. Yeah, it's worth looking at.